As dawn light spreads across the rugged canyon landscape, the future site of how China built the $300
We've analyzed the weather patterns across 3 seasons now. The groundwater impact on the slope stability is our main concern for the foundation.
Comparing the DTM against the survey data confirm the tower placement here.
Agreed, this span length requires the high-grade steel specified in the materials report.
Cement plants process limestone, clay, and other minerals through crushing, heating, and grinding operations that create the cement required for large bridge foundations. Here, enormous steel sections are meticulously cut, welded, and inspected, preparing thousands of tons of material for the massive canyon bridge. Straightforwards. Heavy transport vehicles carry materials, delivering steel segments, machinery, cables, and support equipment, while the steel segments from the North Convoy are arriving on schedule.
Acknowledged. We are preparing the cranes now.
How China built the $300 million bridge over a massive canyon.
If you enjoy process videos like this, please like and subscribe.
How China built the $300 million bridge over a massive canyon.
Blades. Precisely positioned deep anchor holes are drilled directly into the solid rock formations. Surveyors verify the alignment.
These drilling rigs create precisely positioned deep anchor holes, penetrating solid rock formations.
Once assembled, the cages are carefully lowered into the excavated pits, forming the primary structural base for the towers. The batching plants work continuously, precisely measuring the aggregates. Mixer trucks then transport the fresh concrete to the foundations where the crew stands ready.
How China built this massive bridge. The concrete batching plants carefully measure cement, aggregate.
As the massive volume of concrete is poured, vibration equipment is essential to remove trapped air and ensure the integrity of the bridge's structural base. To ensure the concrete develops its intended strength, protective coverings and moisture control systems are utilized, constantly monitored by our equipment.
Assembling the formwork systems and installing the reinforcement is critical before the successive concrete lifts can gradually raise the towers above the canyon.
The massive climbing formwork system allows the crew to continuously repeat the process of reinforcement and concrete placement.
We need to verify the structural tolerance on the main span.
The instruments show we are within the acceptable margin for error. Proceed with the lift.
Elevated crews work hundreds of meters above the canyon floor as massive climbing cranes deliver concrete and reinforcement. Achieving perfect alignment across the canyon required millimeter precision. Now, with the towers complete, how China built this $300 million bridge over a massive canyon, removing large volumes of rock from the mountainsides. The construction of the massive anchor blocks requires careful positioning of dense steel reinforcement within the canyon excavations. The core temperature is rising faster than projected.
We need to activate the cooling pipes immediately to prevent thermal stress.
Verify the coordinates for anchor set 4. We need absolute precision here.
The scanner confirms the position within tolerance. Tension.
To bridge this colossal canyon, engineers first had to construct the specialized tensioning and winching systems on the rim. Spanning this massive canyon requires unprecedented engineering. The tensioning machinery and giant cable reels are the heart of the operation. At a cost of $300 million, the bridge requires these suspended platforms to allow workers to install the massive cables across the span. These elevated catwalk systems were critical. They stretched between the towers high above the river, ensuring the safety of the cable installation teams.
The tension on cable 4 looks stable.
What about the secondary connections near the tower? As the full process continues, thousands of individual steel wires are added to the growing cable bundles, monitored closely by the workers. Contributing to the final cable geometry, specialized measuring systems ensure this massive structure remains within precise tolerance limits. This process transforms thousands of separate wires into dense structural cables with carefully controlled cross-sectional dimensions.
Make sure the tension is correct here. We need to maintain structural performance.
Workers are attaching cable bands along the main cables, creating precisely spaced connection points for the suspender cables that will support the bridge deck. These bands are crucial, creating the precisely spaced connection points where the suspender cables will support the bridge deck high above the canyon. How China built the 300m bridge over a massive canyon. The full process. This is the critical stage where the vertical suspenders are connected, forming the network that supports the massive deck.
The installation of the main suspenders requires absolute precision.
All right, keep the tension steady on the hydraulics. We are almost there.
The installation of the suspenders is a critical phase, requiring millimeter precision to ensure uniform load distribution across the massive canyon span. Here at the fabrication yard, these colossal steel deck sections are welded, inspected, and coated before their journey to the bridge site.
All right, easy now. Bring it up slowly. Clear on the left. Keep coming up.
How China built the $300 million bridge over a massive canyon.
Securing these massive segments requires pinpoint accuracy, constantly monitoring the wind and structural load. Using heavy lifting systems, the crew secures the initial segments, battling wind and structural load to extend the bridge deck. The massive steel segment is lowered with millimeter precision. Once aligned, the permanent connections are secured, followed by a rigorous structural inspection. The massive steel segments must be aligned within millimeters. Once secured, structural inspections ensure the integrity of the connection. The massive deck segments are extended symmetrically from both sides. This technique ensures balanced loading on the towers and cables high above the canyon floor. The deck is extended symmetrically from both sides, maintaining balanced loading on the towers and the cable system high above the canyon floor. Cable tension is verified. The alignment remains precise. Good. Let's move to the next section immediately.
The alignment on section 12 looks good.
Yes, the elevation is within tolerance. Let's proceed with the next measurement. From these elevated platforms, the crews guide massive steel sections across the canyon, ensuring perfect alignment before the welding can begin.
How China built the 300m bridge over a massive canyon. Full process.
The final central deck segment, weighing hundreds of tons, is precisely lowered into the 20-meter gap.
Deck geometry and connection tolerances are confirmed. Everything is aligned.
Cable forces verified. The span is secure.
Deck geometry and connection tolerances are confirmed. Everything is aligned.
Cable forces verified. The span is secure.
Feeler gauge confirms the connection tolerance.
Confirmed. All parameters are within design requirements.
Crews are installing the final deck support systems, including drainage components and the massive expansion joint assemblies designed for thermal movement. Crews are installing critical deck support systems, including drainage components and the expansion joints designed to accommodate thermal movement.
The deck preparation is critical. Workers clean the steel surfaces, apply protective layers, and install waterproofing systems to shield the structure.
To shield the structure from environmental exposure, the steel is meticulously cleaned, coated with protective layers. The density reading is stable at 98%. Noted. The smoothness profile looks good across this section.
Keep the paver steady at 3 meters per minute. Ensure the thickness is uniform across the lane. Ensuring consistent surface characteristics is paramount as the final pavement layers are added to the massive bridge.
The final stage involves securing these edge protection systems, enhancing operational safety for the future traffic crossing this massive bridge.
Hold it there. A little lower on the right. All right, secure it now.
The installation of maintenance walkways and protective railings throughout the bridge, providing safe access for future inspection and maintenance personnel. The installation of these protective railings ensures the long-term structural integrity and safety of the bridge.
Integrating the structural health monitoring system is crucial. allowing technicians to track the bridge's performance in real time. These conduits carry the fiber optic network, essential for the bridge's structural health monitoring system.
The ratings from the cable sensors are consistent with the projections. Yes, the deck movement analysis confirms stability even with the wind.
Sensor activated. Are the cable force readings stable?
Yes, within tolerance. Temperature variation looks good too.
Sensor Array 7 is active. Cable tension looks stable.
Confirmed. Data stream is normalizing across all parameters.
Before the bridge enters the testing phases, crews meticulously verify coating thickness and adhesion quality, ensuring complete coverage across the massive structure.
How China built this $300 million bridge over a massive canyon. The engineers are now preparing comprehensive load testing procedures.
The stress levels in Section 4 are stabilizing perfectly.
Confirmed. All readings are within tolerance. Look at the data spike here.
It's within the acceptable threshold. The design is validated.
Increase the pressure by 5%.
Reaching the target now.
Data confirms stabilization. Tension levels are optimal.
The expansion joints show minimal wear, well within expected parameters.
Confirmed. Are the structural codes fully compliant for wind resistance?
Yes, the simulations confirm stability. We can grant operational approval.
Make sure that sign is secure.
Final safety check on the cables is complete, boss. Looks good to go.
All right, everyone, clear the deck.
All readings stable, Chief. Consistent with simulations.
Excellent. The structure is sound.
How China built the 300M bridge over a massive canyon, Boris.